In this video, we're going to go over section 11.3 lecture notes about combinations. A combination of items occurs when the items are selected from the same group. No item is used more than once. And the order of items makes no difference. So the order is not important. So this is different from permutation. Note that permutation problems involve the situations in which the order matters, and combination problems involve situations in which the order of items makes no difference. In these two examples, we're going to determine which involve permutations and which involve combinations. Example 1. 6 students are running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second highest vote getter becomes vice president, and the student who gets the third largest number of votes will be treasurer. How many different outcomes are possible? So since it's based on the amount of votes that each one is going to get, this is a permutation problem where the order matters, since the highest 3 votes determine the office. So they're going to have a specific positions that they will hold. Example 2 is stating 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? So they're just selecting 6 people. They're not going to have a specific positions based on any particular order. So this is an example of a combinations. The order in which the 3 people are selected does not matter, since they are not filling different roles like in the previous example. So now we're going to compare combinations and permutations. Given the letters A, B, C, D, we can compare how many permutations and how many combinations are possible if we choose 3 letters at a time. So out of the 4 letters, if you choose 3 letters, so you can have ABC, ACB, BAC, BCA, CAB, CBA. So each one of these 4 columns, they represent combinations. So the order doesn't matter. So it creates the 4 columns, the 4 categories, I will say. And then permutation, the order does matter. So that's why each one of this, that's why I label them 1 through 6, 7 through 12, 13 to 18, 19 through 24. So there are 24 permutations because the order, the placement of the letters does make a difference. So this is a very good example to show you the differences between combination and permutations. So there are 4 combinations, the order doesn't matter, and there are 24 permutations and the order matters. So the formula for combinations is here, and I'm going to show you with a calculator how to get the answers. So how many 3-person committee could be formed from 8 people? So you read this as the combination of n objects choosing R, and this is a formula that you will be able to use on the test. So I will demonstrate how to get the answer with the scientific calculator that I called Diego. So in this calculator, we're going to enter, you always enter n first in both calculators. So, and then here we're working with combinations, so it's going to be the second choice, and then you enter the 3. So the final answer is 56. That's how this answer was generated. So for the other ones, I will enter 6, press PRB, and in this one we're choosing 2. So we press 2, and the final answer for this one is, as you can see, 15. I'll leave it down so that we can see it better. For the next one, 19, choosing 5. So we clear the screen. 19, PRB, enter, not PRB, number 2, enter. And then is 5. So this one is 11,628. 11,628. On the next one, 18, choosing 6. 18, PRB, scroll down to number 2, and then 6. So that is 18,564. 18,564. And then here, again, we'll use a calculator. 31, choosing 2. So 31, PRB, option 2, and choosing 2. This is 465. And the last one, I will also demonstrate if you do this by hand. This is 9 factorial, and in the denominator it will be 9 minus 4 factorial, then 4 factorial. So if you come across a question that cannot be completed with a calculator, you can simplify it by hand. So 9 minus 4, that's 5 factorial, and then we have 4 factorial. So the way you simplify these a little bit by hand, this is going to be 9 factorial. I'm going to go down until I get to the highest that I have in the denominator. So what I mean by that is 9 times 8 times 7 times 6 times 5, and then I stop there at the factorial, and then I have 5 factorial. So this will cancel these two, or they become 1. And as for the 4 factorial is 4 times 3 times 2 times 1. So then I can simplify this. I can say 9 divided by 3 is 3. 8 divided by 4 is 2. And 6 divided by 2 is 3. All I have is 7 divided by 1. So to clean this up, I'm going to have 3 times 2 times 7 times 3. 3 times 2 times 7 times 3. Divided by all of these. This was canceled. The 4 was already simplified. That's why you can put a 1 in here just to show you that you have used it. So this is basically 3 times 2 is 6. Times 7 is 42, times 3, 42 times 3, it should be 126. So, but if I do this in the calculator, I should get the same answer. So it's 9 choosing 4. So in the calculator, you enter 9, PRB, option 2, and then 4, and that gives you the same answer. So you can do it by hand if you want to. And there might be some cases, as I mentioned earlier, that you do not have a choice. You might have to simplify by hand because the calculator doesn't have the capacity to give you that large answer. And that's it for the video. Thank you so much.